In the last videos, we have seen how we can able to work with bit manipulations. In the linked list, okay, in the linked list, somewhere we have completed single linked list implementation, and we finished double linked list, double linked list implementation also we have seen. But as a part of continuation for this, we have circular linked list is also there, but we didn't cover that. Let me finish those two programs now. What are those two programs? Circular single linked list means what? In short form, it is called as circular single linked list, CSLL. And in the same way, so circular double linked list. Okay, you know very well about single node means what, double node means what. We are going to talk about these two now. Okay, sir, what is mean by circular single linked list? You can able to see the data will be in the form of circular fashion. For example, if you want to understand, I'm going to take a diagram like this. Okay, the data will be associated with which form? Circular form. Sir, consider this is nothing but my first node what we have. Okay, and it is connected to the second node, and this one is connected to the third node. Sir, generally in the single linked list, if all the nodes are completed, last node is always pointing to the none or null. But in the case of circular single linked list, the last node is connected to the first node. This is the magic. But in the case of circular double linked list, how the nodes will be there? So it will be associated like this. But you know very well, if you take double nodes, three fields will be there. One pointer is pointing to the previous node, so this node next field is this one, and this node previous field is this one. So second node next field is a third node, third node previous field is a second node, and third node next field is nothing but which one? First node, sir. And the first node previous field is which one? Last node. Have you observed? Like that, links will be there. The conclusion here is you won't get a none value. That means we can't see the ending phase in this linked list. Okay, this is nothing but what we have. So such a type of linked list is called as what, sir? Circular single linked list. Of course, we have to implement a program to demonstrate these kind of things. Okay, anyway, don't worry, I will explain in detail about that. Okay, sir, is the style which we are using for representing this linked list, is it clear for you people? Is the concept is clear? Please confirm. Good. So what are the operations that we are going to perform on circular single linked list? First, we are going to see creation of circular single linked list class. After that, we are going to see creation of node class. Okay, we have to create two classes. One is the main class, which is nothing but CSLL. Another one is nothing but what? Node class. And then we have to create creation of so constructor, creation of so constructor for so circular single linked list class. Similarly, we have to see creation of a constructor for node class. And after this, I am going to implement a function to return size of the linked list, something like so size function we will implement. After that, insert operation, I'm not going for all the insert mechanisms, because in the single linked list and the double linked list itself you got so much confusion. But if you practice, you can able to implement. That's why I'm going to take only two functions, like how to insert at first and how to insert at last. Similarly, we are going to see how you can able to print the list next. And after that, so delete from first, how to delete the data from first, and how to delete the data from last. So these methods we are trying to implement now, sir. Okay, these methods we are trying to implement now. Sir, one by one I will demonstrate. So to explain these concepts, let us go with a Python program. Okay, so I'm going to take the Python program. I'm selecting a new Python program. Let us give that Python program name as, okay, so here I'm going to save this one as in the test folder. I'm going to save with the file name. So circular single linked list.py, CSLL.py. So first we have to create the class, right? What is the class name? So class circular single linked list. Inside this, we have to take one more class to represent the node. Inside this, I'm going to define a constructor and it is going to represent data field and then next field. If you are not passing any next field, the default value for next is nothing but what? None. So self dot data will become the data what we have, and self dot next field will become next field whatever you have given. Suppose at the time of creating the node, if you are not passing next pointer, in such cases what will happen? It is going to take the next pointer as a none. Okay, and I want to define constructor also for circular single linked list class. Inside the constructor, I don't want to take the first pointer. I will always take pointer which is pointing to the last node. Okay, because no need to take two pointers. What is the purpose of two pointers? One is always pointing at the beginning, another one is always pointing at the ending. But here my requirement is I want to take only one pointer which is pointing always at the ending, which is going to point always at the ending. So that what will happen? So we can easily get the first node, right? How you can get the first node? Last node next field is pointing to the first node. In that style we can get. And similar to this, self dot count is equal to 0. Sir, as of now, how many elements are there in the single linked list? At the very beginning, I am going to take count is equal to 0. Suppose get a size function I am going to implement, so which is going to return how many elements are there. For that we assigned a separate attribute, right? That is going to return. This is nothing but the first part what we have about circular single linked list. If you take this program, the implementation of this so creation of single linked list class got done, completed. Then creation of node class also we have seen. Then how to create a constructor for circular single linked list class, so we finished. So after this, how to create a constructor for node class, this one also we have seen. And how to get the size of the linked list also we have completed. Are you clear with this first half of our implementation? Please confirm everyone. Is it clear? Come on, please speak out. Clear up to this? Right, good. So what is my next requirement here is I want to create a function like insert at first. What is the function name? Insert at first, which is going to take a data field. We have to insert this at the very beginning. How to write the code? Sir, the newly created node I am taking, new node is equal to, so self dot node of I am giving the data as well as none. Sir, assume in very beginning, so is there any tail pointer, sir? No, right? So there is no tail pointer. If no tail pointer is there, it is pointing to none, right? Yes. Now I am creating a new node. This is nothing but a new node what we have. What is the name of this node? This node name is nothing but a new node. Consider data is nothing but a 10. Okay, our data is nothing but something like 40, like this we have. Okay, sir, what we need to do is we have to attach this one. Okay, guys, 1 second, please wait. One emergency call, please wait. So you can see 40 is nothing but what? New node what we have. Now, is there any elements in the linked list? No, right? That's why the node which you created will become which node, sir? First node. But anyway, once if you create a new node, our default instruction is nothing but what? Self dot count will become self dot count plus one. We have to increment the value of count by 1 unit. This is very common approach. Now we are going to check. Is self dot tail is equal to none? If self dot tail is equal to none, then what is the meaning? We don't have any elements in the linked list. Then, sir, in such cases, self dot tail will become new node. Okay, self dot tail will become which one? New node. Sir, from this diagram, this none will be gone. In the place of none, what we are doing? We are bringing this into the none. Excellent. Sir, after this, what we have to do? This is nothing but which node, sir? Tail node. As of now, remember, this is nothing but the tail node. Sir, okay, fine. After this, can I stop the program? No. Why? Because we have to connect, right? So new node dot next field will become new node itself, and then return the control. So what is the new node here? 40. Its next field will become 40 only. And this node name is nothing but what? Tail. So that the task got completed. This is the way how you can able to insert a new node. Sir, second time I am going to perform insert at first. Sir, can I say is it my node? Yes. So consider the node which I am trying to insert is 30. What is the name of this node, sir? New node. Now onwards, this is not your new node. This is the new node. Sir, is a new node got created, count value will be incremented. Is self dot tail is equal to none? No. It is pointing to some memory location. If it is pointing to some memory location, then it will come out from this, and new node dot next field will become so tail dot next. Okay, new node dot next field will become tail dot next. Can I say this node will be inserted in this position? Yes. So the name of the node also we have to take. Sir, what is the instruction that we have? New node dot next. This is the new node. Its next field is pointing to tail dot next. 40 is the tail. What is a 40 next field, sir? 40 only. So it is attached to this one. So first link got completed. What is the next link? Your tail is there, right? So that next node is pointing to newly created node. Sir, we have our tail is there. This is nothing but the tail. Its next field is pointing to which one? Newly created node. Sir, if you take a link like this, automatically this link will be gone. That's all. So is a newly created node came or not? Yes. Where we inserted that? Insert at first. Sir, very simple operation. Insert at first. I think you people got very clear clarity how we established the links. Everyone feeling comfortable up to this? Come on, please speak out. Clear? Guys, I need response. Right. So the next operation, sir, I want to perform insert at last. What is the next operation that we need to do here? Insert at last, DEF. So insert at last I am taking, where I will take a self and then data field. Sir, first step is as usual, right? We are going to create a new node with a data field, and the next field is pointing to none. As usual, this is common. And self dot count will become self dot count plus 1. We are going to add one value, and now I am going to check is okay. So self dot tail, okay, is self dot tail is equal to none. Then what is the meaning? We don't have any elements. Then the process is same, right? Tail will become new node. Okay, and your new node dot next field will become what? New node only, and then return the control. Sir, otherwise what will happen? Do you know? New node dot next field will become, okay, so tail dot next. Tail dot next. Like this we have to assign. This is nothing but which one? Insert at last. Okay. Now listen. I'm going to create a new node. I'm going to create a new node. I will change the color. Consider this is nothing but a newly created node. So the name of this node is nothing but 50. Sorry, content is nothing but 50, and so it is called as a new node. Where we have to insert this, we need to insert at last. So I am taking this one at the ending. Now, what is the formula that we have taken? New node dot next. Okay, so new node dot next will become tail dot next. New node dot next, sir. New node next field is pointing to tail dot next. Tail is 40, so this 40 next node. What is a 40 next node, sir? Sir, is it 30 or not? Yes, now we are connecting these two. Now we are connecting these two. Automatically this link will be gone. Sir, do you have temporary, sorry, tail node? Yes. New node. Now we have to connect these two. How we are going to connect? Sir, tail dot, tail dot next field will become new node. Am I right? So tail dot next field will become new node, and you need to change the tail. Okay, because the tail node is pointing to the last. That's why I am taking tail node is equal to which one, sir? New node, and then return the control. This is the way how you can able to perform insertion at the beginning and insertion at the ending. I think you people got very clear clarity how to perform this insertion operation from the beginning and from the ending. Are you clear with this? Now where tail pointer is pointing, so tail is always pointing at the ending, and this is not a tail. Sir, clear? Please confirm everyone. Right. So what is the next operation here is I want to perform display operation. So something like I'm going to take, so print list function I am going to take, which will take self, and it is going to print each and every element. If self dot tail is equal to none, that means if there is no element present in that, then what is the meaning? Sir, can I say that linked list is empty? Yes, we are going to print the message saying circular single linked list is empty. I can't display the elements. When it will be happen? If tail is equal to none. Otherwise, what we have to do? I'm going to take temp is equal to, so tail dot next. Tail dot next. Sir, now let us traverse this. I'm going to take some different color for you to understand. Yes. So temp will become tail dot next. Tail is 50. Its next node is nothing but 30. So now I am making this one as a temporary node. Now we have to check. While is that a temporary node is not equal to, so tail dot next. No, tail like this I am checking. Sir, 30 is it equal to 50? No. Then we have to print that temp dot data. Okay, and I am going to give end is equal to some space. Then after that your temp will become, so temp dot next. Like this it is keep on working. Now cross check. Now this temp is pointing to which node? 40. Is this field is a tail? No. Then print that data. So 30 got printed, 40 got printed. Now we are pointing this node to this one. Okay, sir, is a temp is pointing to tail? Yes, it will come out from this one value is pending, right? So after coming out from this loop, you can print temp dot data, which will print that last data. That's all. Beyond that, nothing in the display function. Now I will run all these things where you will get clarity. Sir, I'm going to create one object like list is equal to circular single linked list. Like this I am creating. Is it a correct name? Yes. List dot I'm going to call print list function. Is there any elements in the linked list as of now? No, right? So what output we will get? It will print the message saying, oh, something different. Yesterday class program I am running. So circular single linked list program we have to run. Sir, as of now, circular single linked list is empty. Sir, why it is empty? Because we have not added any content. Okay, sir, now I am going to add print list dot. Let me take, so list dot insert at first. insert at first. So I'm going to take insert at first 10 and insert at first 5. Okay, so insert at first 4 like this, and insert at last 20. So insert at last 30 like this I'm taking. If you print the list, what output I'm expecting? First we inserted 10, after that we inserted 5. Operation is inserted first, so that 5 will be added at the beginning, then insert at first 4, next insert at last 20, insert at last 30, like that I'm going to get. If you want, let us run the code and see. 4 5 10 20 30, is it correct? 4 5 10 20 30, like that if you are getting, sir, we can say. So all the operations like insertion at the beginning, insertion at the ending, okay, and the display operation, all these things got completed. Any doubts friends up to this whatever I covered? Please confirm. Is the concept is clear up to this whatever I covered? Please confirm. Right. Sir, now the next one we have to talk about delete operation. Okay, we need to talk about delete operation. I'm going to remove all these pointers from here so that you won't get any confusion. Sir, now let us see. I want to perform deletion from the beginning. So def delete from first. Okay, delete. Otherwise, delete at first. Delete at first. I'm going to take the pointer as a self. We are not required to pass any element. Okay, now we are going to check. Sir, how you can check whether the list is empty or not? Sir, can I take, so self dot tail, otherwise can I take count? If self dot count is equal to 0, if there is no elements are there, I can print circular single linked list is nothing but what? Empty, and then return the control. Sir, otherwise what we have to do? We need to perform delete operation immediately, that the count value will be reduced by 1 unit. Sir, after that we are going to check, is the tail is equal to, so tail dot next. Sir, when this situation will happen? If you have only one node is there, suppose consider in the diagram I am taking, if you have only one node is there, its next field is pointing to the same node. Consider the data is 10 and this is nothing but a tail node what we have. Sir, tail is equal to tail dot next. Yes. Now we have to remove this element. In such cases, what we have to do? Sir, very simple operation. You are going to take that tail is equal to none and then return the control. Because if you have only one element is there, that element will be removed from the list. Okay, if you have only one element is there, that element will be removed from the list. That's all. Otherwise, what we have to do? So tail dot next field is there, right? Tail dot next field is there, right? It is pointing to tail dot next, because we are doing which operation? So delete at first. Okay, now observe in this diagram I am going to show tail dot next. Which is a tail? Can I say is it a tail? Last element, its next field I am going to pointing to. Okay, so tail dot next, what is the tail dot next? 30, its next field 40. So tail dot next field will become like this. So automatically what will happen? This link will be deleted, and so tail dot next is equal to, okay, 40 means this link also will be deleted. Okay, like this we have. So this is the way how you can able to perform which operation? So deletion from the beginning. Sir, can I delete from the ending? Yes, the same operation we have to do to perform deletion from the ending. Let us take, so delete at last I am going to take, where we have to pass the self, and the base condition is the same. If the value of count is equal to 0, then I am going to print circular single linked list is empty. So otherwise return the control. Okay, so then we have to take count is equal to, so self dot count minus 1, one value we are going to reduce. And if tail is pointing to, so tail dot next, that means we have only one node is there. In such cases I am going to make a tail is equal to none, and then we are going to return the control. Sir, otherwise, we have to do the modifications to the last, right? How you can able to do the modification? Sir, you have a pointer to the tail node, but we don't have any pointer to the previous node. Okay, that's why you need to get the previous. How you can get? Sir, for our convenient purpose, I'm going to change in the diagram, like I'm going to take the previous diagram like this. Assume just we have a diagram like this. So in this, I want to delete the element from the last. So what I am going to do is, I will declare one separate pointer called temp, which is pointing to the beginning. Okay, so I'm going to take temp is equal to tail dot next. That means what? Which is pointing at the beginning node. Now I'm going to check, is that a temporary node? Okay, is that a temporary node next field? Is that a temporary node next field is not equal to tail? Sir, here what is the temporary node? 30. What is the next field to 30? 40. Is it a tail node? No. Then what we are doing is, temp is equal to temp dot next. Now this temporary node is pointing to, okay, 40. Sir, temp dot next 40 next node is not equal to tail. No, it is equal to tail. So it will come out from this. Have you observed why I have taken that? I think now you got clarity, because to remove the connection between these two I have taken. Now how to remove the connection? So this temporary node is there, right? Its next field is pointing to tail dot next. As of now, what is the tail dot next? Tail is 50, its next node is 30. That will become temporary node next. Okay, sir, temporary node next field is pointing to tail dot next, which is nothing but what? 30. Like that we have. Okay, fine. So that means what? This link got a break. Okay, sir, after this what we are going to do? The next step is, your tail is there, right? That the tail is pointing to temp. That the tail is pointing to temp. Sir, this tail is pointing to which one? Temporary node. Now onwards, this is not a temporary node. Okay, so this one will become temporary node. Sorry, this one will become tail node. That's all right. So if you do like this, automatically these links will be break. That's all. This is the way how you can able to remove from the ending. Okay, so delete at last, delete at first, it is very clear for you. So let us run the code. As of now, how many elements are there? So 5, 4, 10, something like that we have. Now I am going to call, so list dot delete at first. Can you please remove the element which is located at first? That means which elements will be there in your hand? 5, 10, 20, 30. Let me check. Sir, 5, 10, 20, 30. I want to perform one more operation, which is nothing but list dot delete at last. So which element it is going to remove? That last element will be removed. After that, if you check the output, what we are getting is 5, 10, 20 like this. So this is the way how we can able to perform circular single linked list application. Okay, so all these operations, like how to perform insert at first, okay, next and after that how to perform insert at last, and next and after that how to print the elements present in the list. Okay, so next and after that, so how you can able to delete the elements from the beginning. Okay, next and after that how to delete the elements from the ending. All these operations I explained very clearly with the help of examples. Sir, are you feeling any difficulty in this circular single linked list application? Please confirm. Sir, clear? Please confirm, friends. right? So the next operation, okay, the next operation, what we are going somewhat, but need to practice. Yeah, confirm, Pranay, compulsory, you need to practice. So the next operation here we need to discuss is circular double linked list. Almost same operations I am going to explain. What are the operations? How you can able to create circular double linked list class, how to create a node class, okay. Next and after that, the creation of a circular, not a single linked list, it is a double linked list. Sir, how you can able to create a node class constructor, how to get a size, okay. Next and after that, how to perform insert at first, insert at last, print list, delete first, delete last. But the only thing which you required is we need additional pointer, except that nothing. I will implement from the scratch. You can see I'm going to take a new Python program and I will save this Python program as circular double linked list.py. Sir, have a look once. First, I am going to take circular double linked list class. Inside this, I am going to define a node class. In the node class, I want to define a constructor, okay, which is going to take self comma. How many pointers will be there? Data field will be there, and the next field will be there, which is pointing to none. And one more special feature we have to take, which is nothing but previous, which is pointing to previous node. And here I am taking self dot data is equal to data, and self dot next is pointing to the next node, and self dot previous is pointing to the previous node. Like this I am going to take. Sir, next underscore underscore init underscore underscore. Sir, I am taking self. If you take circular double linked list, sir, tail field is required, but in addition to that, I am going to take head field also, okay, because double pointers we have to assign, right? That's why I am taking. And self dot, how many elements will be there as of now? 0. Then you know that I am going to implement get size function, which is going to return in the linked list how many elements are there. Sir, now we will go with one by one. Sir, somewhat complexity will be there here. Please try to understand. I am going to take insert at first. Insert at first. Sir, I am going to give the data field. We have to insert the data at very beginning. Sir, how to do that? First, I am going to take the example like this. Consider I am going to create a new node like this. Okay, minimum I will take 3 nodes to explain. Please listen. So this is nothing but new node what we have. So what is the data field? Assume the data field is nothing but 40. Okay, so previous node is none, next node is also none. Sir, what about head? Your head pointer is pointing to none. Your head pointer is pointing to none. Even your tail pointer is also pointing to none. Both are pointing to none as of now. Okay, so now we are going to create the node. New node is equal to, so self dot node of the given data whatever you have given, and the next field is none, previous field is also none. Okay, sir, once if you create a new node, can I increment that count value by 1 unit? Yes. Now can you please check, is tail is equal to none? Yes, that means we don't have any elements. If you don't have any elements, whatever node you created, that will become your tail pointer, and whatever node you have created, that will become your head pointer. Excellent. Sir, now listen carefully. I am going to remove this head and then tail, okay, which is not pointing to none. It is associated with some content. Sir, what is that content? Which is nothing but the newly created node. What is the content of that node? 40. Now head pointer is pointing to 40, tail pointer is also pointing to 40. Like this we have. Now listen friends. Sir, with this the story is not completed. Still the story pending is there. What is that? Is we have to link, right? Newly created node, next field I am going to assign to new node. Newly created node, previous field I am assigning to new node. Then return the control. See, when we are inserting first time, this is nothing but what will happen. Sir, next field, previous field will be gone. Now listen, the newly created node, sir, next field, because for convenient purpose, I am going to expand this diagram. Please try to understand. Okay, sir, your newly created node, next field is pointing to the same node, and your newly created node, previous field is also pointing to the same. This is the way how you can able to make the links. Yes, first node we created. Okay, up to this, do you have any doubts? Please confirm. If everything is clear, I will try to insert two more nodes and I will explain. Clear, friends, up to this, whatever I covered? Right. Sir, now what we are going to do is I'm creating another node. This is nothing but another node what we have. Sir, what is this node? I'm giving this node name as a new node. Once if the function got executed, this is not new node. Consider its data is nothing but a 10. So previous field is none. Next field is also none. Now cross check. Is tail is equal to none? No, sir. Then what will happen? It will come out from this. What we need to write here? So you need to attach this at the beginning. Sir, we have to write 4 pointers. What is the first one here is your newly created node is there, right? Its next field is pointing to, sir, self dot head. Your newly created node is there, right? Its previous field is pointing to head dot previous. Okay, now listen how I am going to make up this. So this node will come here, that we know, and the next field is not none, previous field is not none. What is the first instruction that we have? New node dot next. This is the new node. Its next field will become head. Sir, is it head or not? Yes. And new node is there, right? Its previous field will become where it is pointing head dot previous. This is the head. Its previous node is pointing to the same. Now this link will be attached. Sir, with this, which links got deleted? So this link got deleted and this link got deleted. Still connections are there. How I am going to write the few more connections? Now your newly created node. Okay, better I will take first head node. So your head node is there, right? Its previous field is pointing to new node. What is the head node here? 40. 40 previous node is pointing to new node. Okay, one extra link completed. Next, your newly created node previous field is there, right? Its next pointer is pointing to new node. This is somewhat tricky instruction. Your newly created node is there. Which one? 10. Its previous field. Oh, 10 previous field is pointing to 40. So 40 next field will become new node. Like this we have. Sir, all the nodes got completed or not? Yes. But head got changed, right? So your head node will become newly created node. That's all, sir. Now this is not your head pointer. Sir, head pointer will become this one. So this is nothing but how you can able to perform. So insert at which operation? Insert at first. If you are clear with this, I will take one more example and I will establish the connections with the red color. Are you clear up to this? Yes, please confirm. Clear up to this? Right. So what is the next one? Sir, next I am going to create a new node. Consider the data of this newly created node. Oh, length become very small. So the newly created node is nothing but what? 5. Assume this is the newly created node. Now we have to insert this node at the beginning. Here we have to insert. Sir, how I am going to attach? Sir, with red color I am going to mark. Please have a look once. Sir, is tail is equal to none? No. First instruction, new node dot next. This is nothing but new node dot next is pointing to head. Okay, that means this link got deleted. Perfect. So what is the second instruction? So new node dot previous is there, right? It is pointing to Head dot previous. Head dot previous is pointing to 40. So this one is also pointing to 40. That means what? This link got deleted. Okay, right. Sir, next after that, head dot previous. Head is a 10. Its a previous node is nothing but what? Head dot previous node. Oh, head dot previous. Actually, that previous node will be there. Head dot previous is what? 40. Okay, that will be assigned to new node. Head dot previous. Head dot previous field will become uh, something is tricky. No, correct only. This link will be deleted. Yeah. So your head dot previous field will become what? Newly created node. And your newly created node previous. This is the newly created node. Its previous is 40. Its next field will become what? New node. Like this we are going to attach. And head will become new node. That means now onwards this is not head. So this will become your head. This will become your head. Like that we have to take. So I think you understood very clearly how this insert at the first function is going to work. Everyone feeling comfortable up to this whatever I covered, please confirm. Right. So the next one, the next one, sir, I want to implement a program to perform insert at last. So def insert at last. How you can able to perform insert at last, we will see. We have to pass a self and then data. So first we are going to create a newly created node, self dot node. So where we are going to pass the current node as a data, and the next field is none, previous field is also none. So next self dot count will become, I am going to take, so self dot count plus 1. Like this I am going to take. And if self dot tail is equal to none, that means what? We don't have any elements in the linked list. We don't have any elements in the linked list. If it is the case, then what will happen? That a tail node will become, okay, newly created node. And so that head node will become newly created node. And your newly created node previous field is pointing to newly created node. And that newly created node next field is also pointing to the newly created node. And we have to return the control. When it will happen? If the list is empty. Sir, my list is not empty. So how you can able to attach? So the newly created node, where you have to attach? Sir, I have to insert at the ending, right? Let us write code for that. How you can able to do? First I will demonstrate here. So this is nothing but a new node what we have. This one I have to insert at the last. Let us consider the content is 50. Now where we need to insert at that? This name is nothing but new node, nn is there. So I want to insert this node at the ending. Here I want to add. How to make the links? That's what we have to see. Now, sir, the first instruction, your newly created node next field will become, so tail dot, your newly created node next field will become your tail dot next. Sir, where is a tail dot next? Where is a tail dot next? Sir, tail is nothing but I am changing with the black color. Tail is nothing but 40. What is a 40 next node? Head, right? 5. So that will become your newly created node next field. Your newly created code node next field will become this one. That means this red color link got completed. Then, sir, after that, what is the next line that we have to take? I'm going to take your newly created node previous field will become, your newly created node previous field will become tail. Sir, what is the newly created node? 50. 50 previous node is pointing to the tail, which is nothing but 40. 40. Once if it is connected to the 40, this one will be gone. Sir, after this, what is the next line? I'm going to take tail dot next field will become newly created node. What is a tail here? 40. 40 next field will become new node. Okay, so after that I am going to take your newly created node is there, right? Its next field, previous node will become new node. Sir, newly created node is what? 50. Its next field is what? 5. 5 previous field I am going to assign to the new node. Like this, almost all the links got completed. But you have to change the tail, right? From now onwards, okay, that the tail will be pointing to new node. That's all. Now onwards, this tail is pointing to the new node. Like this, we can able to add the element at the beginning of the linked list and at the ending of circular circular double linked list. Are you clear with this insert operation? Please confirm. Right. Now we have to perform display operation, sir. I think no need to explain the display. Directly I'm going to write the code. You can understand. DEF, I am taking print list. So which is taking self as the parameter. Sir, when we can say list is empty, can I take is tail is equal to none, means we are going to print circular double linked list is empty. We can't able to insert any element into this, and simply I am going to return the control. Sir, otherwise what we are doing, temp is equal to, I am going to take, so tail dot, okay, tail dot next, that means it is assigned to the head, and until the value of temp, okay, value of temp is not equal to tail, until it is not becoming to the tail, I am going to print that a temporary node data field, and I am going to make end is equal to space. Then your temp will become what? Temp dot next. Like this we are keep on moving, and at last I am going to print, so temp dot data field. At last I am going to print temp dot data field. This is nothing but how you can able to print the list. Sir, I will write the code. List is equal to, I am taking circular double linked list. Sir, by using this list, can you please print list? Sir, what output we are going to get? Initially it is empty, right? So py space circular double linked list. Circular double linked list is initially empty. Can you please add the objects? List dot, sir, I am going to take, so insert at first I am going to take 40, insert at first 30, okay, so insert at first 10. So then I want to see the list. What output we will get? 10, 30, and then 40, because these are inserted from the beginning. Now I want to insert at ending. How you can able to insert? Can I take list dot insert at last of, I'm giving, so 50, and I'm going to give 60, and I'm going to give 70. So these three values will be added at the ending, like you can say 50, okay, 50, and then 60, and then 70. Sir, now we have to check whether it is working or not. Yes, but how to perform delete operation I will explain. Sir, with executable code, sir, how you can able to insert from the beginning and how you can able to insert from the ending, is these two operations are clear for you people, friends? Please confirm. Please confirm everyone, is the concept is clear up to this whatever I covered? Right. Sir, next I am going to take delete. So delete at first. How you can able to delete from the beginning? We have to write code for that. Sir, let us see how to delete from the beginning. In this example, if you call delete from the beginning, for 5 should be deleted. So how you can able to check? First, if the count is equal to 0, sir, can I print the message saying circular double linked list is empty, I can't able to insert, and then return the control. Sir, otherwise what we are going to do? We can delete First try to reduce the count value by 1 unit. Okay, so after this, can you please cross check, is self dot count is equal to 1? See, assume we have only one node is there, so that count is not equal to 0. We reduced that count to 1, that means count is equal to 0. So initially we have one element is there, after performing delete at first, that element is also gone. In such cases, list will become empty, right? Can I take tail is equal to none? So can I take head is equal to none and return the control? That's all. Otherwise, what we have to do? We need to delete the element present at the beginning. I'm taking temp is equal to head dot next. What is the head dot next? Can I say head dot next is nothing but this one, right? 10. So I'm taking this one as what? A temporary node. Why? Because if you want to delete this, you need the name of this node. That's why I have taken. Sir, after this, temp dot previous field will become tail node. What is a temporary node? 10. So 10 previous node. This is the 10, right? It's a previous node I am assigning to the tail. Sir, if you assign like this, can I say this link will be deleted? Yes. Sir, after that, what is the next statement that I am giving? Your tail is there, right? Its next field is pointing to temp. What is a tail field here? 50. So 50 next field is pointing to temp. That means this one. Can I say now is this link also got completed? That's all. Sir, after this, what we are going to take is that head will become temporary node what we have. That's all. So that head will become which one? Temporary node. Which is the temporary node here? Sir, temporary node is nothing but a 10. That will become head. Automatically this link will be deleted. Automatically these links will be deleted. That's all. This is the way how you can able to perform delete at first. Let us check in this code. I am going to call, so list dot delete at first. Sir, is it going to delete the first object present in the circular single link list? Let me check. Is that object got deleted or not? Yes. This is the way how to work with delete at first. Everyone feeling comfortable up to this? Please confirm. Clear? If you are okay with this, I will go for delete at last. Sir, now we have to write code for delete at last. Almost same operations, right? What is the first operation? We will check is that a count value is equal to 0. Then we can say circular double linked list is empty. We can't able to insert any value and return the control. Otherwise, what will happen? Your count value will become, so count minus 1. Like this, I am going to take. After this. So if your count value is becoming 0 means, so your tail field will become none and your head will become none. That double linked list will become empty. Okay, that double linked list will become empty. Okay. Sir, after this, what we have to do? Suppose if these fields are already available, then what I am going to do is again take the same story, sir. Temporary field will become self dot tail dot previous. So now which one will become temporary? I am marking in green color. So can I say this field will become temporary field or not? Yes. Why? Because it is previous to tail. Okay. After this, what we have to do now? Temp dot next field will become, so head node. What is a temp node here? 40. So 40 next field will become what? Head node. That means, so this field will be deleted. Right. After that, what is the next link that we are going to remove? Your head is there, right? It's a previous field is pointing to temp. Okay, your head is there, right? It's a previous field is pointing to temp. Sir, your head is there, right? It's a previous field is pointing to temp. That means this previous link is also gone. Okay, automatically these two links will be deleted. Sir, now what is the next instruction? I think you understood very clearly. Your tail node will become which one? Temp. So now onwards, so this tail will become which one? Temp. That's all. So this link will be deleted. This is the way how you can perform. So delete at last. Let me do this. Sir, I am going to take list dot delete at last function I am taking. Automatically, which element it is going to delete? 70. If you want, you can cross check. So this is the way how you can able to perform. So insert operation, delete operation, so counting operation. So all these things in which linked list? Circular double linked list. Almost 100 lines of code we got. I think you people got very clear clarity. So with this linked list story got completed. Sir, all these methods we implemented or not? Yes, this one is done. This one is done. This one is also done. Okay, sir, do you have any doubts up to this whatever I covered? Please confirm. Any doubt in all these operations whatever we covered? Please confirm, everyone. Guys, please respond. Clear up to this? Right. Right, sir. So with this, the story of linked list got completed. Okay. Somewhere we kept pending this one. Today we finished this. Now, so linked list got completed. Sir, now I'm going to explain dynamic programming today. Okay, what is mean by dynamic programming? When we can apply this dynamic programming, I will explain. Dynamic programming, sir, in short form it is called as a DP. I will explain the problem statement and one example program for this dynamic programming methods. Sir, what is this meaning of dynamic programming? Before moving to this dynamic programming, I want to take one example. Okay, I want to take one example. So from that, I will show you what problems we are going to face in that, and to overcome that problems, we are going for the dynamic programming. First, I will show you what is mean by this dynamic programming, what problems we are going to get in this. Sir, do you know it is same like recursion? How you have seen recursion, in the same style dynamic programming will be there. Okay, but dynamic programming means recursion with optimized, okay, with optimized, okay, optimized solution. Optimized solution is nothing but DP, dynamic programming. Dynamic programming means what? Recursion with optimized solution. Sir, first I will explain one example program. So without dynamic programming, okay, I am going to calculate Fibonacci sequence. How you can calculate Fibonacci sequence number, I will explain with the help of normal recursion. I am not including the dynamic programming, so that you can able to understand what is mean by DP, why we need the DP. Assume I am taking one function called FIB, which will take n, and I am going to take if the value of n is equal to 0 or if the value of n is equal to 1, I will return 1. Otherwise, what we are going to do, fib of n minus 1 plus fib of n minus 2, like this we are going to take. This is nothing but what is mean by dynamic programming. Sir, now what is this, sorry, what is mean by Fibonacci sequence? Sir, what is the Fibonacci sequence numbers? 0 1 1, okay, next and after that 2 3, next and after that 5 8 13, like this we will get. So in my point of view, I am going to take, so print of fib of 0, Fibonacci digit for 0th number. Sir, what output we are expecting? 0. If you pass Fibonacci of 1, sir, what output we are going to get? I think here we have to count from 1, sir. This is the first number. Here, instead of 1, written n. Now see what output we will get. Sir, first uh, py space test.py. You can see, sir, 0 and 1. Okay, fine. Now I am going to take fib of 2. What output we are expecting? 1. Now I am taking fib of 3. Sir, what output we are going to get? So this is 0th Fibonacci number, first number 2 3 4 5, so 6 and then 7, like this. For third Fibonacci number, the output is 2. For fourth Fibonacci number, the output is nothing but what? 3. Okay, for fifth Fibonacci number, the output is nothing but what? 5. Like this we are going to get. Is it correct? Yes. Now I don't want all these things. Please focus on fourth Fibonacci number. Actually, what is happening here? If you elaborate with the diagram, I am going to take Fibonacci of what is the input that you have given 4, right? Sir, is the value of n is equal to 0? No. Is equal to 1? No. Then it will be expanded in two formulas. One is fib of n minus 1, which is nothing but 4 minus 1, 3. And another one is what? Fib of, sir, 4 minus 2, which is nothing but 2. Now, again, this f of 3 is divided into two phases. So f of 3 minus 1 means 2. So f of 3 minus 2 means 1. And this one is again divided into 2 minus 1, 1, and 2 minus 2, 0. And this f of 2 is again divided into, okay, this f of 2 is again divided into f of 2 minus 1, 1, and f of 2 minus 2, 0, like this. So until in the bottom level, until you are getting 0 or 1, it will be expanded. Now this value, what value it will return? 1. And this function is going to return 0. 0 plus 1 will become 1. This one will return. And 1 it will return. 1 plus 1 will become 2, it will return. And here it is going to return 1. It is going to return 0. 0 plus 1 will be returned by 1. And what is the output that you are getting for this program? Sir, it is nothing but 3. 3. Up to this, do you have any doubts? Please confirm. Up to this, do you have any doubts? Please confirm. Is it clear? Now the problem here is, sir, I will show you whether you are going to understand or not. Please listen. The problem here is f of 1 here we calculated. Sir, again we are calculating here. Again we are calculating here. F of 0 we calculated here. Again we are calculating here. F of 2 we calculated here. Again we are calculating here. Sir, can I say these underlines whatever I kept, these are unnecessary, right? Because if f of 1 is already calculated, what is the need to recalculate? This is called as overlapping. If you want how many times these functions are going to be calculated, we can count. I'm going to take one global variable called c. Okay, so whenever this function got called, I'm going to increment that global value. Sir, at the end, I'm going to print number of calls. Now see, for this program, how many calls it is going to be taken? Sorry, c is equal to, we have to declare as a 0. Now see, Sir, how many method calls is there? 9 method calls is there, sir. Unnecessary calls will be there. If you want, you can count. Sir, I am marking with some color. Sir, listen. This is the first method call, second, third, fourth, fifth, sixth, seventh, eighth, ninth. How many method calls? 9. Can I reduce this? Yes. So this is one call. This is one call. This is one call. This is one call. Sir, 1, 2, 3, 4. This is one call. 5. These are sufficient, sir. Because f of 1, is it required to calculate? Already here itself we calculated. Substitute that value. F of 2, already we calculated here. Substitute that value. So the number of method calls we are going to reduce. This concept is called as what? Dynamic programming. Sir, everyone, have you understood what is mean by dynamic programming internally? Please confirm, everyone. Yes, guys, please respond. Everyone, please confirm what is mean by this dynamic programming. Is it clear? The problem statement. Right. This is nothing but without dynamic programming, okay, reducing the number of method calls. Yes, Pranay. This is nothing but without dynamic programming, sir, how many method calls are required? This is the problem what we have. Now we can implement, okay, we can implement dynamic programming. We can implement dynamic programming by using the following methods, by using the following methods. So to reduce overlapping, okay, overlapping method calls, if you want to reduce overlapping method calls, you can go for this dynamic programming. There are two approaches are there, sir. One is nothing but memoization. This is nothing but by using recursion we are going to see. Second one is tabulation method is there. So tabulation means here we are going to use either arrays or list. By using that we will take. Okay, sir, I will give the solution example for Fibonacci problem. So using by using memoization, how you can able to find the solution. Listen carefully how I am going to reduce the number of method calls. Listen carefully, friends. See here, whenever we are implementing like this, so in addition to this Fibonacci number, okay, I'm going to create one list object. I'm going to create one list object with every value as a 0 into n plus 1. Sir, where n is nothing but to which number you want to calculate Fibonacci number. Okay, so until that we are going to take, that means we will get a list with how many elements? 5 elements. Parallelly I will take diagram. So we are going to get a list with how many elements, sir? 5 elements. 0th location will be there, first location will be there, second location will be there, third location will be there, fourth location will be there. Sir, what are the default values for this? Every number will become 0 as of now. Okay, fine. While calculating the Fibonacci number, along with the number, I'm going to pass that list also. Of course, I know output is 3. Along with that number, I'm going to pass the list. Now, what we are going to do? Sir, if the value of n is equal to 0 or if the value of n is equal to 1, I will return n. Otherwise, I will check in that list, is that number is not equal to 0. That means it is already there. If already there, why you need to calculate? Simply return. Sir, otherwise if the element is not there, can you please calculate L of n? So by taking fib of n minus 1, so plus fib of n minus 2, after calculating, can you please return that number? So if any new number is coming, then we are calculating that number and we are returning. If it is already existing, simply return. Now see what will happen. I'm going to take with the help of example. Sir, first I called Fibonacci of 4. See how control is going to be happen. So first it is going to check. Is the number is equal to 0? No. Is the number is equal to 1? No. is L of 4. L of 4 is what? 0. It is not calculated. Now calculate. So L of 4 will become, so FIB of n minus 1. That means FIB of 4 minus 1 is 3. FIB of 4 minus 2 will become, sir, 2. Then FIB of 3, again it will calculate. Sir, is that value is there? No. Then what will happen? It is going to be calculated for 2 and it will be calculated for 1. Then again it will expand f of 2. Sir, it will become f of 1 and then f of 0. Sir, now if you came to f of 1, sir, is this value, is it required to compute? Yes, we have to compute. So what is its value? When n is equal to 1, its value is 1. That means 0 means 0. 1 means it is written that is stored value called 1. Sir, that value will be there. So it will return 1. Okay. It will return 0. Okay. Now what is the value of L of 2? 1 plus 0, which is nothing but 1. Now that value will be written. Sir, f of 1. Sir, will it calculate? No. Already that value is there. So that will be written. This one won't call. Now f of 3. What is its value? Sir, 1 plus 1, which is nothing but what? 2. That 2 value will be written. It will calculate and it will return. Now, sir, what about f of 2? Is that value is there in the symbol table? Yes. Now take that value 1. No need to calculate. So 2 plus 1 will become 3. Who called this? For them, it is going to return 3. This is nothing but what will happen. Sir, how many method calls? This is one call, second call, third call, fourth call, fifth call. In the previous example, sixth, seventh, eighth, ninth calls will be there. Now this ninth call got reduced to 5 calls. If you want, I will run the program, same program, you can see. Sir, FIB is missing one positional argument called list. Here also in the recursion, we have to pass. I forgot. Now see, sir, how many method calls? 7. 7 is coming. Something is wrong here. Can you please cross check FIB of n? See if n is equal to 0 or 1, we are going to return n. If L of n is not equal to 0, return L of n. Otherwise, L of n will become FIB of n minus 1 of L, FIB of n minus 2 of L, return L of L. And then why 7 calls are coming? One minute. If you take the number is equal to 5, how many calls? For this I have example, 9 calls should be there. Yes, correct only. How this 7 is coming? Previously we got 9 calls, now it got reduced to 7. Let me check which calls will come. This is the first method call, second method call, third, fourth, fifth, maybe sixth and seventh. But this one is not evaluated, 7 and 8. Okay. And if you take number 5, okay, for 5 Fibonacci number, you will get a big tree. From that you can get clarity. Okay. This is the way how we can able to solve this problem by using memoization. Sir, at least some method calls are reduced or not? Yes. Sir, everyone feeling comfortable about this memoization, how it is working? Yes, please confirm everyone. Right. Sir, next problem is what? I want to go for tabulation. Okay. I want to take this example for the Fibonacci number by using tabulation. Sir, what is this tabulation? It is also same, sir. In the recursion, whenever you are implementing by using functions, it is taking definitely more time. Suppose if you are calculating for Fibonacci of 3 in the previous example, sir, maximum 9 calls, minimum 7 calls is taking. But still it is a difficult, right? Because we have to calculate third Fibonacci number of method calls is increasing. That's why I don't want to go for that. Better to go with loops only. So in the loops, what I am doing, I will take a list which can hold n plus 1 elements. Then I'm going to take the first number as a 0. Why we need to create again a function? Second number as a 1. And for each I value in the range of 2 to n plus 1, this loop will calculate L of I will become L of I minus 1 and L of I minus 2. Why we need to go for recursion? So unnecessary calls are coming. That's why can you please reduce like this? That's all. And if you take n value from the user, n is equal to, so enter any number like this. I am going to ask, sir, now what we are going to do? Simply we will call fib of n. Here we can't count how many method calls will be there. Only one call will be there because we are not using any functional approach here. Now see, if the given number is 5, output is 5. If given number is 4, 3 is the output. If given number is 6, output is 8. Like that, we can calculate Fibonacci number by using tabulation. Tabulation means what? It is a normal native approach what we have. Okay. So in Fibonacci number, in how many ways we can find the solution? As of now, we got 3 ways. What is the first way? By using loops you can solve. Second way is what? By using recursion we can solve. In the recursion, if the number of methods calls are increasing, we can go with dynamic programming. These are the different ways are there how you can able to find the solution. Okay, everyone feeling comfortable up to this whatever I covered? Please confirm. Right, sir. So this is nothing but what is mean by dynamic programming and how you can able to work with this dynamic programming. So remaining things we will continue in the tomorrow's class. Sir, tomorrow I will explain sorting algorithms and searching algorithms. That time complexity calculation is there, right? That I will explain tomorrow. As usual, we have a class at 7 o'clock. Okay, so where I will explain this sorting and searching algorithms summary, and greedy algorithms also I will explain. Okay, one simple program, and I will start a hash table also. Okay, so these three things will be covered in tomorrow and the day after tomorrow. 2 days I am going to plan for this. And after this, so we start a tree data structure, and then we will go with the priority queue and then graph. Maybe next week I can able to wind up. Sir, next week this graph data structure I am going to take in the same timings like Saturday and Sunday. So next Sunday will be our last class. Okay, I will close the syllabus by the next week. Thank you guys. Remaining things we will continue in the tomorrow's class, and I will upload these running notes within few minutes. You can download. Thank you.